Okay, more properties of logarithms. Okay, so here I have three different expressions here, and we are going to write down another alternate way to write these down. So this will be a property of logarithms that we can use. For the first one, the log base b of m times n, you can write this as log base b of m plus log base b of n. Multiplication becomes addition. For this one, log base b of m over n becomes log base b of m minus log base b of n. And what about this one? This becomes p times log base b of m. So look at what's happening here. This is really interesting. The logarithms are taking the order of operations down a notch, right? Most people would agree that multiplication is one step above addition, right? Well, this is taking a multiplication and bringing it down to addition. It's taking division, bringing it back down to subtraction. Taking exponentiation, taking it down a notch to multiplication. So that's a really useful aspect of logarithms. Now, what I want to do is take a moment and prove this, all right? Let's just see, why is this true? Well, let's start with the right-hand side, all right? Well, if I want to investigate this, I think one natural thing to do is to try to use the inverse function, okay? So here we have three properties. I want to do a proof of property 1, okay? So to see this, I'm going to start with this and take it as an exponent on b. What do I get when I do this? Well, remember properties of exponents, right? B to the x plus y is the same thing as b to the x times b to the y. That's a property of exponents. Well, I can use that property here. Here I have b to the x plus y. I can write that as b to the x times b to the y. Well, how can I write this? Well, remember, these are inverse functions. They cancel off. These are inverse functions. They cancel off. So what do I have? I have m times n. These are multiplied, so these are multiplied. Now, let's interpret this. This is saying that this guy is an exponent on b that gives m times n. What's the exponent on b that gives m times n? That's the log base b of m times n. So that must mean that this is equal to, by definition of logarithms, must be the log base b of this, m times n. And so we've proven number 1. And you should, as a challenge to yourself, it's not really a challenge, I think it's pretty straightforward, following the same line of reasoning, essentially the same, a little bit different, you can prove these other two. Okay, that's just how we prove these. And these are going to be useful for us, especially because they're allowing us to take order of operations down a notch. And that's really exploited a lot when people use these in the sciences. If you ever heard about somebody making a log graph of something, that's what they're doing. They're trying to take something that was kind of complicated and they're making it simpler. Okay, so let's take a look at these. What we want to do is simplify. See if we can simplify these expressions. The first one we're going to do is log base 3 of 3 times y. Log base 3 of 3 times y. Well, look, I have a product of two things. The log of a product is the sum of the logs. Remember, log takes products down a notch to addition. So this is going to be log base 3 of 3 plus log base 3 of y. Now, what's log base 3 of 3? Well, it's the exponent on 3 that gives 3. Well, that's just 1. There we go. Okay, let's try another one. Log base 7 of 49 over t. Well, remember what log does to division. It makes it into subtraction. So this is going to be log base 7 of 49 minus log base 7 of t. What's log base 7 of 49? Well, remember, it's the exponent on 7 that would give 49. Well, we know that that is 7 squared. 49 is 7 squared, so that the exponent is 2. Okay, so we were able to write this like this. Let's try another one. Log base 2 of 64. Now, you might be able to do it a different way than I'm about to do it. You might be able to see what it is, right, just by using the definition of logarithm. But let's try it this way. I'm going to observe that, hey, you know what? I know that 64, well, that's 8 squared, right? So this is log base 2 of 8 squared. Well, we have another property. It takes exponentiation and turns it into multiplication, right? This is 2. This thing comes down. 2 times log base 2 of 8. That was our third property. Log of m to the p is p times log of m. Right? So that p came out front. Now what's log base 2 of 8? Well, it's the exponent on 2 that gives 8. That's 3. And so the answer is 6. Log base 2 of 64 is 6. Okay, so we've used each one of those properties. Let's use them a couple more times. I want to expand this out. Expand. Well, what do they mean by that? Well, it means to use these properties. I don't know if you noticed, but when you use these properties, it's a little bit bigger, right? So what's the first property I see in here? Well, I see division, right? Division. So I can use the quotient property of logarithms, which says that I can write that as subtraction, right? So go ahead and do that. Pause the video, work it out. All right, welcome back. Let's see what we got. I'm going to write that as subtraction. Okay, now what can we do? Well, let's look in here. Here I've got multiplication, right? It's 4 times x to the 6th. I can write multiplication as addition. And what about this guy? Well, let's leave this guy for now. We'll take care of him in the next step. Now, can I do anything about log base 5 of 4? I don't think so. That's as simple as that one's going to get. I can't simplify that anymore. However, this one, we have an exponent, so we can use the exponent property here. It says the exponent comes down out front as a multiplication. Exponentiation becomes multiplication. So this one becomes 6 times log base 5 of x. What about this? Square root of y. Can I do anything with that? Well, if you think about it, you should realize that square root of y, let's write it up here. Square root of y is the same thing as y to the 1/2 power. So it is an exponent. So I can bring that exponent down. So the 1/2 comes down. So there you go. We've expanded this out. And notice we took these complicated operations like exponentiation, multiplication, and division and the square root, and we've written them all as simpler operations as we've done that. Pretty cool, huh? Okay, so now let's try condensing something. Let's do the other way around. Condense that guy. Okay. Okay, well, what can I do here? You know, if these numbers weren't here, I could just combine them using that quotient property. You know, subtraction becomes division, right? But there's numbers out here, so let's take care of these numbers first. How can I take care of these numbers? Well, that's using that third property in the reverse. I'm going to go from here to here. So the p is going to come up as an exponent. Well, that's what we're going to do. This 1/3 comes up as an exponent. So that is the same as log base 3 of 4 to the 1/3. And same thing over here. The 2 comes up as an exponent. Okay, well now I've just got log. I don't have numbers out front, so now I can use this property here. I see there's no numbers out front. That's when you can use it. This becomes the log of a quotient, right? So let's use that. This is going to become the log base 3 of 4 to the 1/3 over x minus 1 squared. And there we go. That's the answer. However, I would say that you could also write it like this. I wouldn't say that one is correct and the other one's not. I'm just giving you an alternative way to write it. We could write it as the cube root of 4. All right. It just depends. That's a matter of taste. Okay, whether you write it this way or this way. All right. So using properties of logarithms. That's what we did today. And I hope you found that useful.